Welcome back to part 13 of this narrated series of videos which sit alongside my A-level chemistry speedrun. These videos are me commentating on my thought process so you know at each stage why I did what I did in the calculation. Today's question is a back titration question, and often students struggle with back titration because they can't really visualise what's happening. So essentially, if we have a solid and we want to know how much of a particular base there is in it, you can't do a titration with that solid. You can't just do a titration and add an indicator and look for a colour change because you've got this big mass of solid and there's other stuff mixed in with it and it's just not going to work. So instead we do this back titration process. So what we do is we react that rock or that solid with some acid, and we know that we've added an excess of acid. We've definitely added too much. And then we use the washings from that to do another titration with an alkali, and we see, well, how much of the initial acid that we had have we got left over? And the difference must be whatever reacted with this solid. So the first thing we're going to do is to look at how much sodium hydroxide did it take to neutralise the leftover acid. So my moles of sodium hydroxide are going to be concentration multiplied by volume. My volume there has been given in centimetres cubed, so I'm going to need to convert that to decimetres cubed. So I'm then going to do 1, which was the concentration, multiplied by 0.015, which is my volume, to get 0.015 moles. Now, because I'm using sodium hydroxide and hydrochloric acid, this is quite straightforward. I'm aware that they react in a 1-to-1 ratio, and therefore my moles of hydrochloric acid will be exactly the same as my moles of sodium hydroxide. Remember, this is the moles that got used up in that second reaction, in that titration. So now I'm going to think about, well, how many moles did I start with? So originally, before there was the reaction with the calcium carbonate rock. So again, I need concentration times volume. So my concentration is there, my volume is there. Again, I'm going to need to convert that volume, and I get an answer of 0.025. Now, the missing moles, the difference between those two numbers, that's what must have reacted with my calcium carbonate. So that's the 0.010 moles. So if I now write an equation for this, and they're probably not going to give you this equation in the exam, you are going to be expected to be able to write a simple equation for an acid reacting with a carbonate. We can see that they're in a 1-to-2 ratio, and my hydrochloric acid is my 2, so if I had 0.010 moles of that, then I must have started out with 0.005 moles of calcium carbonate. Now, you've got two options at this point. You could work out how many moles there should be and do it like that, or you could work out what mass of calcium carbonate this would be and do it like that. Either way, we're just using those two numbers together to make a percentage. So the relative formula mass of calcium carbonate, if I add all those relative atomic masses together, is going to be 100.1 grams per mole. And so if I only had 0.005 moles, then that would be 0.5005 grams. And so that means that my rock had 0.5005 grams of calcium carbonate out of a total of 4 grams, the original rock. And then to make it percentage purity, I need to multiply it by 100%. And that gives me an answer of 12.5%. Thanks very much for watching, and I hope that you're finding the speedrun series helpful. If you are enjoying these videos, then don't forget to like and subscribe for more A-level chemistry content coming soon.